Okay, so hello everyone, and welcome to today's talk in the Responsible Use of Data seminar series organized as part of the Academic Fringe Festival. I'm Juana Inel, and today I'm really excited to welcome and introduce Vera Liao as our speaker in this seminar series. Vera is a research staff member at IBM TJ Watson Research Center in New York City, working in the trusted AI area. Her research background is in human-computer interaction, and she is currently focusing on human-AI interaction, explainable AI, and conversational agents. She was awarded the IBM Outstanding Research Accomplishments for contributions to IBM's Watson Assistant and Trusted AI Toolkits. Vera publishes regularly in the area of human-computer interaction and intelligent user interfaces, from which she also received numerous awards. She received a PhD in computer science and a Master of Science degree in human factors from University of Illinois at Urbana-Champaign and a bachelor's degree in industrial engineering from Tsinghua University. So today, Vera will talk about questioning the AI towards human-centered explainable AI. So before I give the floor to Vera, I would like to mention again that this talk is going to be recorded and made publicly available in a couple of days on YouTube. You can post your questions during the talk in the chat. And at the end, I can either ask the question or you can unmute and ask the question yourself. So without further ado, the floor is yours, Vera. We are very happy to have you here as a speaker.
Thank you. Thanks for the introduction. Very excited to be here. Kudos for the organizers for putting together such an amazing event. So I want to share some work that my colleagues and I at IBM have been doing on the topic of human-centered expandable AI. I want to first say a few things, just situate the kind of work we do. So at IBM, I work under this trusted AI area. Most of my colleagues are AI researchers. They develop AI algorithms. One line of work we do together is to put out these open source toolkits on topic related to trustworthy AI. Some people say responsible AI, including explainability, fairness, robustness. Fact sheets is about AI documentation and governance. I'm super excited to share that we just released a new one last week and uncertainty quantification. So this 360 series of toolkits are to make state-of-the-art techniques developed in the academic world more accessible to practitioners, data scientists. We always also include educational material and try to cultivate community around this topic. So please check them out and hopefully you can use them in your work. And the one I spent significant time on was the one on explainability in 2019 and recently on the uncertainty one. But as an HCI researcher, I often see the release of the toolkits as the beginning, not the end of our work. So we want to do this bridging work to think about how do we help practitioners to make better use of this toolkit? How do we bridge this toolbox of AI algorithm into toolbox of design material? So hopefully by the end of work or by talk, you have some idea how we do this bridging work using explainability as a test bed. I also want to say that probably compared to other speakers of the series, my work is more on the downstream user interaction and design rather than data per se. But the way I see responsible AI means first and foremost to put users' needs and well-being first. And to do so, one way to do so is to have the right design first and use the design vision to drive technical development, including the construction of model and data. Hopefully my talk gives you some of that perspective. So what is explainable AI? I think there are two definitions going around. A lot of AI researchers adopt this relatively narrower definition, are techniques that make a model's decision process understandable by people. So the keyword here is the decision process. But if you talk to practitioners, this word is often used more liberally to cultivate a holistic understanding of the AI. Users might also be interested in explanation of the data, of system function, of performance, and so on. So AI is not just machine learning, but our work, and I would say the majority of the field focus on explaining supervised machine learning, given that it's still the most popular AI technology. So that's also going to be the focus of this talk. So you probably have heard the term explainable AI or interpretable machine learning in academic work, industry, even in popular press. It's also in legislation, right? GDPR is the European law that require the rights to explanation whenever there is automated decision system. One of the reasons, obviously, because AI is being increasingly used everywhere, including high-speed domain like healthcare, finance, even criminal justice system. So in those domains, if the AI does not work reliably, the outcome can be disastrous. And also users tend to be more cautious. If you hand them a black box model, I tend to use the term opaque box model, they may be hesitant to use. So there's also the trust and adoption issue. But one of the reasons that we have such an active technical field, there's so many different algorithms being developed, is because at the current time, at least in the average setting of training machine learning model, there is a performance explainability trade-off. On the one end, you have a model that's relatively easy to understand, like linear model, decision tree, rule-based model, but they tend to not perform very well. On the other end, you have popular high-performing model like deep neural network, ensemble model. They perform well, but they tend to be complex, opaque, and not really following human consumable reasoning. So a lot of techniques are developed to tackle this challenge. And if you look at the technical landscape, they generally fall into two camps. One is what we call directly explainable model. And recent work is also trying to break this trade-off to develop new algorithm, more sophisticated rule-based model or linear model that works better, but still preserve this property of being relatively easy to understand. On the other side, we have what's called post-hoc explainability. It's when you already choose to use opaque box model, like a deep neural network, you will need another set of techniques to generate explanation. That's what we call post-hoc. One of the examples you have probably heard is this algorithm called LIME. It's one of the most popular explainability technique. What it does is it will treat this complex model, for example, a neural network you're using, as an opaque box. And trying to explain a particular prediction, and it just look at the input and output of this opaque box. It also sample the neighboring instance and building a simpler model, a linear model in the local region, and use this simpler model to explain the complex model's decision in this local region. It's very popular because it's model agnostic. Whatever model you use, you can use LIME. And the explanation form is what we call feature contribution, right? To explain a particular prediction, it highlights the important feature that contribute to this decision. If you're using a tabular data, you can visualize which feature make the highest contribution. If you're using image data, you can highlight a superpixel or patches of the image that contribute to this decision, that there's a cat. Or if you're using text, you can highlight the keywords of the text that contribute to the decision. So LIME is just one example. There are algorithms to explain the general model logic. We call global explanation. LIME is an example of a local explanation, explain a particular decision. Another category, what we call inspecting counterfactual, is when you're interested, how do you change the current instance to get a different prediction? So the technical landscape is not a focus of this talk. If you're interested, I encourage you to check out this course material we taught at Kite. There I gave an example of how this different algorithm, their output look like, how they work. But this talk, I want to focus more on the HCI and design side of the work. So this is a growing field. Every year, hundreds of more papers published in this area. And also a growing collection of them are making their way into practitioners' toolbox by way of this kind of open source toolkits. IBM is only the only one. Every big tech company have their own toolkits, also some startup. So now practitioners have access to this toolbox. They're eager to take up the technique and they want to build XAI system. This different kind of system can serve many domains and different user groups. I think we're really at a kind of agile point. We'll start seeing more XAI system in the real world. But there is a sobering question of how will practitioners use this toolbox? Will they use those at all? We actually know very little about how people interact with AI explanation or how to design XAI system. So with that motivation, I see our work happening in this in-between space of have this toolbox of XAI algorithm and take them to build XAI user experience. And I also hope our work can help practitioner also work in this in-between space. And one particular role is AI designers, broadly defined. So user experience researcher, UI designer, they will work in this in-between space. So whenever these practitioners have access to this kind of toolbox, they need to answer two questions. One is how to select the most appropriate technique for a particular application, user group, even interaction. And second is how to translate. It's often not ideal to just show the raw output of an algorithm. So how do we translate the reasoning of AI into users' term? So to help answer those questions, we do two lines of work. One is we study the design practice, understand this design space, and try to develop design method to help doing this design work. In another thread, we do this selection and translation work ourselves. We look into different use cases of an XAI system. We design a system. We conduct HCI research. And by doing work in this in-between space, we also hope to bring real-world insights into the technical community. One is to contextualize different XAI algorithms, where they might work, where they might fall short, and also to inform gaps and opportunities to develop new XAI algorithms. So I want to start with the second thread is our HCI research with different XAI use case. My goal today is to give you an overview of what are some important use cases for XAI and how this explanation might look like. I will not delve into the research detail or the technical detail, but I will provide reference. But if you're curious, feel free to interrupt me, but I will also try to leave like 10 minutes at the end of my talk for QA. So there are different ways to think about XAI use cases, and one lens we look into is this AI lifecycle, how the model is developed, how the model is used. And I also like to separate between the model development side and the model deployment side. So we have looked into different use cases in this AI lifecycle. I want to pick a few use cases that are people commonly talk about when we think about explainable AI. The first use case is to use explanation to improve model debugging and selection during model development. And here the user of explanations are data scientists. It is also the area where beginning to see more XAI system first. So not delving into too much. So here are some example of recent HCI work developing this kind of XAI system UI to help model developer. The key motivation is we know currently when people develop model, they look into performance metric. But we want developer to go a step further to actually inspect the model behavior. And then you will see whether the model will behave reasonably in the deployment context and whether you are making wrong assumption with the data with the model. So one kind of shared property of this kind of system is that they often leverage multiple kinds of explanation. Data scientists want to inspect a model at multiple levels, right? They want to see how the model works globally, how it weighs different features, does that align with their reasoning? They might also want to dive into seeing a subset of data or a particular part of the input space. They might even want to inspect a particular instance, for example, where the model makes wrong prediction. And these kind of interfaces are also tend to be relatively complex use visualization as the user data scientists, they are well adapted with this kind of interface with visualization. And another use case people commonly talk about explanation is to use explanation to better support decision makers. So I would say most machine learning systems at the present time fall into decision support or AI-assisted decision making, where the model gave a recommendation and the human decision maker will use that information, but they will have the final say, they will make the final decision. And explanation is useful in this context. One reason is explanation give more information to help the decision making and also help decision maker to take action. One example is, so IBM has this system called Watson supply chain. There's AI behind to tell you, I'm predicting this delivery might be late. And talking to the designer, we learned that users really want explanation because the explanation can determine their follow-up action. Is this a weather reason they cannot do anything about it, or is there somewhere they can make a quick phone call? So to support follow-up action. And another reason in this context, people want explanation is to support fine-grained trust calibration. At the prediction level, knowing that when to trust AI and when not to. For example, with this prediction, if you're seeing the explanation is problematic, you might be more cautious and resort to your own judgment rather than AI's explanation. So that is the kind of hope, but I want to highlight that empirical results is actually not as optimistic. Both our own work and some of the recent Kite paper have this pretty robust observation that explanation can lead to unwarranted trust, even though when you should not trust AI. So we conducted this experiment using this income prediction data set and a pretty simplistic explanation visualizing this feature contribution. We find that when, for instance, that the model has low confidence, where you really should not rely on the model, showing this explanation versus not showing explanation, people are actually more likely to trust the model. And overall, showing explanation actually somewhat reduce the overall performance. So that kind of, there are two lessons here, right? One is you have to evaluate whether explanation is perceived correctly by the user, right? Even though theoretically, this kind of explanation can give you hints that the model is ambivalent if you look at the overall contribution bar of the visualization. But user actually misled. They might be linked to having explanation itself to signaling competence So there is perception bias or limitation you have to think about when you design explanation. And second lesson is there are other ways to alert user when the model is uncertain beyond explanation. And that's also our motivation to develop the newer toolkit on uncertainty quantification. And another third use case people commonly talk about explanation is to support model auditing for regulatory body, for impacted group. And one main reason is to audit whether the model has biases, whether there's fairness issues. So fair ML is its own topic. It's a very actively researched field. I believe some of the speakers in the series has also covered the topic. At a very high level, fair ML means that so machine learning model is to learn pattern from historical data. Disparity is a given. But when this disparity puts certain unprivileged group at a systematic disadvantage, whether racial group, age group, gender, disability, this should be considered unfair, biased, even illegal in certain contexts. And one of the most high profile case to think about the fairness problem is Campus. Sorry, Campus is a machine learning system used by some part of the criminal justice system in the United States. There's a machine learning model to make recidivism risk prediction. It looks at the profile of a defendant and make a prediction whether this person is likely to reoffend. And judges can look into this kind of prediction and take that into account when they make sentence decision, for example, whether to post bail, how much to post bail. The problem is that the Campus is trained in historical data where we know the criminal justice system, the policing system has certain biases. So the model can exhibit the same kind of bias. For example, if you show the profile of similar defendants but different races, the model can give different prediction. So this case is made public aware by a group of activists. It also really marks the beginning of a lot of discussion around fair ML. We're also seeing a lot of technical work in the field in the past 5 years also. A lot of this technical work focus on one is to measuring different kinds of biases of the model, another is to debias. But the common consensus is also we should not automate this process. We need to have human in the loop to inspect whether the model has bias, what kind of feature has bias, and choose the right debiasing technique. And this is the place we see the intersection between explainability and fairness. So explanation can be used as the interface to help people to better scrutinize discrimination or biases. So we have this paper published in 2019. What we did was we took actually the Campus data set and replicate that model. And we generate 4 kinds of popular types of explanation. And we conducted user experiments to see whether this explanation can help people better judge the model fairness. We also had ground truth of fairer and unfair models. So generally, we find that all these different kinds of explanation can help, but through slightly different mechanism. So first, we have this contrastive explanation on the upper left side. So this is a type of counterfactual explanation. It's to tell you which feature, if I change or perturb, often implying minimum change, will get a different prediction. So this explanation really highlights this individual fairness problem that similar people are treated differently just because the kind of racial feature. And second, we have example-based explanation, which does not get into the rationale of the model, but to show you there are similar cases that had a similar outcome. And here it highlights that this is an ambivalent decision because there are only 60% of people had a similar outcome. And that alert people this may be an unfair decision. And at the bottom, we have two, we often say global explanation that get into the general model logic. One is the feature importance, which show how the model weighs different feature. And another is to show the data distribution. So these two kinds of explanation highlight this group fairness problem that the model treats different group in different way, and there are fairness problem. So these different kinds of explanation helps answer the question, is the way the model makes risk prediction fair, and is this person treated fairly? So looking through across this kind of different use cases, there are a few lessons we learned. One is, perhaps not surprisingly, there's no one-fits-all solution. Different use case, different user needs different kinds of explanation. And real-world XAI system also often needs multiple types of explanation at global level and local level. And the challenge is to anticipate when and where user want what kind of explanation. We also need to use the toolbox responsibly. We need to beware the potential risk of XAI. They can lead to unwarranted trust. They can create distraction or information overload. In some of our work, we also highlight this disparate effect that when you show explanation, right, one group of user, they might have the capability to make sense of explanation, and another group, they might not. So these two groups can have different experience. They might also have different level of trust with the AI system. And the last 2 points are related. One is that we see there is an underdeveloped translation design space. The work does not stop at choosing the right algorithm. There's still a lot of design decision to be made to create the right user experience. And one of the reasons is because users' information needs to achieve understanding of AI can go beyond just algorithmic explanation. And that also points to a fundamental challenge with XAI is that understanding lies in the recipient. Just making the algorithm transparent does not guarantee the recipient can understand it. So that's why also GDPR is getting some criticism with this word meaningful information. Meaningful is up to interpretation, it depends on the recipient. So there's also like this underspecified aspect of this law. So for this reason, we often encourage our designer to center the analysis on users' information needs to achieve understanding instead of just how do we make this model transparent. And by doing that, you will quickly realize that there are other kinds of information or knowledge gap to achieve understanding, right? The user might need to first understand how AI works in general before they can make sense of the particular explanation. There can also be domain knowledge gap. For example, you need to first explain what a feature means in the particular domain before showing the feature. And our recent work also discuss that understanding is also socially situated, and especially because consequential AI systems are often embedded in its own socio-organizational context. So people also need to make sense of this social organizational context before they can make sense of the AI, make sense how they can use the AI. So we have a Kite paper published last month. We propose to expand this design and conceptual space of explainability to also make visible the social organizational context around the AI system. And one way to do so, very much inspired by the CSW literature, is to make visible past users' interaction with AI and their reasoning around AI interactions. We call it social transparency. We have this half conceptual, half empirical piece at Kite. You're welcome to check that out. So this is also a good place to switch to the other thread. I think designing explainable AI is challenging. The translation space is underdeveloped also because There are many different user objectives for people to seek explanation. Recent work starts summarizing what are the key user groups that need explanation. But I still believe the granularity is not enough. For example, decision maker in a healthcare domain versus in a financial domain, they have different knowledge with AI. They also have very different practice. So at the end of the day, we need to understand the nuances of the usage context, the user needs. We need to have user-centered design process. So that motivated us to do another thread of work is to study the design practice on the ground and think about user-centered design method. So we started with this work we did in the summer of 2019, right after we released this AI X360 toolkit. So we went to interviewing designers that work on different AI products within IBM. My goal is to answer one is, what is this design space of explainable AI? A bit forward-looking, given that it's an emerging technical space. And also, what are the design challenges? So to interview designer, very quickly, why run into this challenge? How do we talk about a technical space that people are not quite in there yet? Designers are not familiar with this different algorithm. There's no shared framework, even terminology to talk about them. So we decided to create a study probe, which brings a concrete representation to ground our discussion. So we developed a list of algorithm-informed XAI questions. It's based on the following assumption. The first assumption I kind of foreshadow you with those little blurb is that user needs for explainability. What kinds of explanation they need can be represented by what kind of question they ask the AI. A how question, a why question, a what if question will require different kinds of explanation. And a prototypical user question can be answered by one or multiple XAI methods. For example, feature contribution is one type of method. A method can be implemented by one or multiple algorithms. For example, LIME can be implemented to generate feature contribution. There are other algorithms to do so. They might differ in computational property, but we want to stay at the granularity of XAI method from a user interaction point of view. So we started with this literature survey. We arrived at a list of different kinds of explanation method, and we map them to what is the prototypical question this explanation can answer. And we are taking this broader view of explainability. So we also added 3 categories of this kind of model facts question. They are related to data, output, and performance. So we have this 9 different categories. We brought those category cards to the designer we interview. We asked them to start with, tell us this AI system you worked on. Before showing them the cards, we asked them, what are some common questions your user have for understanding the AI? Then we walk each cards and discuss, does this question apply to your use case? Did we miss anything? So the middle 2 steps of the interview, what we're essentially doing is to quote unquote designer source common questions people have for understanding AI. We gathered more than 300 questions and then we did an analysis. One contribution we try to make is to develop this XAI question bank. It is an extendable repository of common questions users have for understanding AI, and it represents this common space of user needs for explainability. We also organize them into this 9 category, which has correspondence to categories of explanation methods. I will come back to discuss how we may use this question bank. I want to first share some lessons we learned around the design challenges. The first design challenge, probably not surprising at this moment, is there's a huge variability. Users ask different kinds of questions for different AI application, different usage points. And one reason is because people seek explanation for diverse objectives, right? Explanation is to support understanding, but understanding itself is rarely the end goal. The understanding is to support some kind of user objective. And there are many different kinds of objective. In the paper, we summarize 6 types. One is to gain insights for decision making. Second is to appropriately evaluate AI's capability, especially common during onboarding stage, and also to adapt usage or control, to learn about the domain, to improve model, and also there is legal and ethical compliance requirements. And the second design challenge is that we see designers struggle with the gaps between algorithmic output and human desired explanation. One paper I recommend everyone to read is this Tim Miller's paper. What he did was to do a literature survey of social science literature to summarize what are the common property of human explanation and use that to guide to see where are the gaps. And we saw a lot of resonance in our work talking to designer. For example, human explanations are selective. When I explain my action, I'm not giving you the whole causal chain. I'm picking courses that I believe that are most informative or sometimes most persuasive. So that is still a design decision to make rather than an algorithm action. And there are other properties like contrastive, interactive, and we need to tailor to recipient. So we also see some interesting translation design attempt, right? Some designer, they start with observing how domain experts explain, and they try to mimic that explanation, both the form of explanation and the terminology they use. What this work really opened my eye is also to see some of the process-oriented challenge, right? When we think about responsible AI, we really also need to think about what is the challenge for people working in this process, right? One is that designers and the practitioner in general, they face challenge navigating the technical capability, given that this is an emerging, rapidly growing technical space. And the challenge is also they need to find the right pairing between what's needed by the user and what's feasible with a given model, with a given algorithm. And another challenge here is they need to get buy-in from data scientists, because data scientists or AI engineer are people who are burdened with either implementing a new algorithm or write additional code to get the right explanation. But the problem is sometimes design coming in too late. A model is already built. There's time constraints. There are communication barriers between designers and AI engineer. There are lack of shared workflow. So those are what create challenge to get buy-in from data scientists. And that really become the barrier for some of the team to invest in or prioritize explainability features. So in the paper, we also did 2 sets of analysis. One is that we look into why these questions are asked in real world use case and try to derive high-level guideline on how to address these different categories of explainability needs. We also did a gap analysis looking into what are some questions asked in the interview that was not in our original list, and that helps us to see where are the gaps for technical XAI work when we summarize that in the paper. But I want to spend the rest of this talk also discuss something came out of this work is a user-centered design process to think about XAI design. We call it question-driven XAI design. I'm working to incorporate this design process also into IBM's design thinking framework as sort of standard way for our designers to think about explainable AI. So to tackle this challenge I just discussed, we propose to have this user-centered design process that start with identify interaction-specific XAI needs, select the right kind of XAI technique, iterative design and evaluation, all grounded in understanding what kind of questions the user asks. And this is also our attempt to bring designers and AI engineers / data scientists work closer to start with developing shared design vision and use that design vision to drive the technical development. So we also suggest that in this process, you can optionally use this XAI question bank as a checklist to help you identify which question is applicable to your use case. And another set of work we did is to create this mapping chart. We take those categories of user question and then we map them to current XAI technique that can answer those questions. We particularly focus on algorithms that are already available in those popular open source toolkits. And every algorithm here has a URL link for data scientists to also look into the technical and implementation detail. And by doing this mapping, we derive the guideline in the middle column, which are explanation to answer these different categories of question. They are strictly grounded in technical affordance. I also want to highlight there are two high-level ideas here. One is that we use question as a way to reframe this technical space of XAI algorithm. So instead of using a data sciencey kind of taxonomy, we want to contextualize what kind of user question each algorithm can answer. And that directly connects to the output of user research. Another key idea here is that we want to use question as a boundary object to support designer and engineer to have collaborative problem solving, where the designer have a clear understanding of what are the user requirements behind the question, and data scientists have a clear understanding what are the technical detail to implement this algorithm. So I have a working paper also put on arXiv that describe this design process, but here I want to use a use case where we actually practice this design process to guide you through this design. So this is a use case that is a project that I actually participated last year. It's a collaboration with other AI researcher as well as our Watson Health team. We're trying to develop an AI system for adverse event prediction. So it tells clinician that what is the risk of this patient for unplanned hospitalization. So doctors can identify who are the high-risk patients and better manage their care. And from the very beginning, we recognize that explainability is going to be the core piece of the user experience because clinicians might not be happy to just see a risk score. They would want to understand reason that will help them better manage patient care. So we decided to follow that question-driven XAI design process. The first step is to identify user question. And this can be just a lightweight exercise when you are doing your user research. So for that project, we started with interviewing clinicians. We interviewed 9 of them. We start with how are you currently doing patient risk assessment, and how would you imagine having an AI system to help you? So we work with them to define this AI task, which is to do risk prediction and help clinician to identify high-risk patients. And at that point, we follow up by asking, imagine have that AI system. What kind of questions do you have? What kind of question this AI system needs to answer to be useful and to be trustworthy? We asked them to every participant we interviewed. So we also asked them, what is the intention and expectation behind, right? Why were you asking this question? What would be a good answer look like? What should a good answer do? For example, one doctor say, I have this question of, what are the main risk factors for this person? And the intention is they want the AI system to help them better understand the patient and discover otherwise non-obvious risk factors of this patient. So we gather these two sets of data, question and intention, and the second step is to analyze that data. One set of outcome is you want to categorize those questions you gathered across different participants. And here you can also use the question bank to guide this analysis. For example, almost all the doctor ask a why question. Why is this patient predict high risk? What are the high risk factor of this patient? Some of them ask how to be that, meaning how can I reduce this predicted risk? What can I do? They also ask about the performance, the data, and output. And after doing this categorization, you also want to maybe do some prioritization. Here is just looking into how many people ask this question, and that help you to know which categories you want to focus on. And another set of analysis is to analyze that user intention and expectation data. You also want to cluster them. And here you want to derive the key user requirements that users want to achieve from the explainability feature. And in this use case, we summarize 4 user requirements, including discover new information, determine next step, increase confidence to use, and also to evaluate the reliability of particular prediction. And the third step is where the designers and the data scientists should really sit together and look into the category, the prioritized category, and map them to candidate technical solution. And here, this big mapping chart can help that discussion. For example, looking into many users ask a why question. What are some algorithms that can answer the why question? And based on the particular algorithm you use, which is the right one to implement. And after getting this set of technique, the last step, data scientists can now proceed with implementation with confidence, and designer wants to create a version of a design that cover those different technique that identified in the third step. We also want to emphasize this should be an iterative process. You create a design, you evaluate with also the user requirements you identified in the earlier step, and then you see where are the gaps, and you want to iteratively close the gap and also keep improving the design. So very quickly, I want to show you this is a design we created, which has a correspondence to the user research, to the user question we gathered in the beginning, right? So this is a AI system that gave a prediction, and we gave multiple kinds of explanation. Many people interested in the why questions. We have this panel to visualize this feature contribution of this particular patient. Why is he predicted high or low risk? We also have this action impact panel is to answer this how to be that question. It's a kind of contrastive explanation showing you which feature you should focus on, eliminate this risk factor, and that can decrease the predicted risk. And with a design iteration, we also link this factor to actionable to-dos that help doctor to know, I want to reduce the pneumonia risk, and what can I do? Maybe you want to order a pneumonia vaccine. We also have, interestingly, this data panel. What we really find helpful with this question is to narrow down to what kind of question, what kind of facts users might be interested, where some are surprised that doctors are really interested in the data. And the reason is because they want to evaluate whether the data align with their patients. Based on the question, we designed this pop-up window that show the distribution of key demographic and also what is the training data, which data set is used. So coming to the end of my talk, I want to give a concluding remark of how do we do this bridging work from a toolbox of AI algorithm to toolbox of design material. I think there are three principles we follow. The first is human-centered. I believe human-centered is not just about design and evaluating with user, with stakeholder. It requires a fundamental shift of perspective to reframe this technical space by the human needs, value, and condition different algorithms serve. For example, what kind of question they can answer. We also need to think outside the toolbox to center an analysis on user needs and goals, and that will also help you to see where this toolbox might fall short. And second is we need to use this toolbox responsibly. We need to carefully examine what are the breakdown, what are limitation of different tools, and carefully label the tools in the toolbox. We also want to enable user-centered design to drive the selection of the tool and drive the technical development. And lastly is we want to make this actionable to support people who work in the process of developing responsible AI to develop assets or methods practitioners can readily use. I also want to say that explainability is important, but explainability should not be the red herring that distract us from other important issues to create this ecosystem of responsible human-centered AI. I often use the example of you don't need to understand how a plane works and you will choose to take plane because there is a whole long-term ecosystem of different regulation, oversight, safety first practice to make sure the plane manufacturer is safe, reliable, and trustworthy. And we should do that for AI as well, looking outside the explainability. And for example, Ben Schleiderman has a recent paper as well as a tutorial to talk about some of the perhaps more important issue beyond explainability to create this ecosystem of responsible AI. So with that, I'd like to conclude my talk and thanks to my collaborators. And I think I have a few minutes to take questions. Thank you.
Thank you very much, Vera. These were a lot of thoughts, a lot of really nice observations that you had. And I am pretty sure that people will have questions about them. Until we get some questions, I do have one of my own. The last use case about the medical decision making, I think that's very interesting. And what I wanted to ask you is whether through all the discussions that physicians or doctors have with AI designers, so domain experts with designers, whether you can actually identify flaws or let's say workflows in the medical domain that might be faulty. So through these explanations, physicians can actually understand that the way they collect data from patients may not be the right way.
Mm-hmm. I can't really answer that question because for that particular talk, for particular use case, that was not our focus, and we didn't really look into that. But I do want to emphasize that one intersection of explainability with the whole responsible AI discussion is on accountability, right? Well, for developer, for people constructing data and model, if they're aware in the downstream interaction, people will be able to understand the model and understand data. That would also encourage more responsible data collection, right? Similar with when we think about privacy issue, when we think about security issue. So that's where I also see explainability intersects with this responsible data discussion, is also facilitate this accountability and facilitate the whole pipeline being accountable and ultimately being responsible. Thanks for that question.
Thank you. We have another question from Stefan. I think you can unmute.
Yeah, thanks. Thanks for the talk. And I like the question-based approach. So I was wondering, have you also looked at how well the technical tools manage to answer these user questions?
Right. Very good question. I'm glad you asked. I do have a slide I didn't have time to get into. Again, it's in the paper. So one motivation for us to do this work is exactly to identify gaps. And the gap analysis we did was looking into what questions was asked by the designers / representing the end user that was not answerable by the techniques, by the question we originally identified by just the algorithm, right? So there's some examples. For example, a lot of questions around data, understanding data limitation and generalizability, while the technical field right now is still mostly focused on the model and the algorithm side. And another interesting example is also, if you think about the system side, not just model, often a system use multiple model. So when user want explanation, they will want explanation of how this multiple model work together. That's another area we're not seeing good techniques. And in general, again, like I think users want, one is interactive explanation. They might ask multiple questions. They might want to dive into different level of granularity. And they also want explanation to be adaptable, right? Users have different knowledge of AI. They might want different kind of terminology, different terms. So interactive and adaptive explanation, I truly believe is where the field should work towards, and something just regardless of what kind of domain that will deliver a lot of value to end users. Yeah, thanks for that question.
Thanks.
Thank you. We have another question from Leonie. If you would like to ask the question, otherwise I can read it, it's in the chat. Okay, so I think I will read the question. It's regarding the social context, and Leonie is wondering what difference it makes if the person that is supposed to understand the AI is involved in or part of the AI's learning process. Like the case of an AI that collects data about the user to make decisions later, and this user is supposed to understand how their traits or behaviors have influenced the AI, compared to an AI that was trained on data not related to the person. It should be explainable too. What do you think about this?
That's an excellent question. I think it is also, we're beginning to see more work in that to answer that question. I don't have a good answer, but we have done some work on what we call explainable active learning. So that's also give explanation of people who are labeling data and give them some view of seeing how their behavior or labeling might impact the model. But there are also a lot of work in interactive machine learning, and we can borrow some lessons there. One is to have a quick feedback loop for people to try and error, see how their behavior might impact the model, impact the decision-making process. And that's also interesting when you point out this intersection with the social explanation kind of work. We should look into that, but I do also think like understanding the social context, understanding how other people's behavior, how collective behavior might impact the model is another interesting direction to explore. Yeah, thanks for that question. I think it's a brilliant question. It's definitely something we should look into. Thanks.
Thank you. We have another question. I think Ujval was the next one.
Sure. Thanks again, Vera. I thought that was an excellent synthesis of some really inspiring work that you've been doing. My question to you is about the question bank that you have, right? And I think through the course of your talk, you did mention how this can be a question bank that can evolve over time. And I'd imagine that this could happen through explorations in different contexts. Could you shed some light on how exactly you envision that happening?
Yeah. I think a straightforward extension and the next piece of work we really do is I acknowledge it's a limitation of work is we're not getting it from end user, right? We're getting it from quote unquote designer source. So definitely there needs work to be done to see what end users are exactly asking. And the question again is context dependent. I believe the use case and context for explanation is also not a fixed set. It will keep growing as people, HCI people or designer come up with different new use cases to use explanation. We will definitely also see new questions emerge. And another thing is also users' behavior is also shaped by technical affordance, right? For example, right now when we interview designer, not many of them would ask counterfactual question, like how to be that, what if? And one reason is just end users are not seeing a lot of that kind of explanation, right? Once we start giving that kind of explanation to user, that will also inspire new questions. So everything here is like the co-shaping of technical development, new use cases, and user behavior. You are going to see new questions emerge where we'll definitely will see the repository keep growing. Thanks for that question. Yeah.
We have one more question from Yun Seo. Oh, and one more, but yeah.
Hi, Vera. Hi. I have one question. So like, thank you for your great talk first. So actually the questioning the AI is one of my favorite paper. And I'm currently working on XAI project, which is targeting the lay people. I think also Ujal like just mentioned that, and like who rather do lighter decision making, such as exploring recommendation in such as YouTube or Netflix. So what I mean is more entertainment domain. So I was thinking like it really depends on the context, but questioning the AI have some improvement to like actually targeting some lay person, I think. So like basically, like as you mentioned in the paper, I was thinking like practitioners' words are too technical. So like, do you think how can we transform them into more user-centered way? Like what I mean is more like less technical heavy way. So I am interested in that part. Yeah.
Very good question. I have a few thoughts. One is I don't necessarily want to give prescribed rule like lay people should do this and do that, because lay people is also a huge heterogeneous group. I think this question-driven process can help is to go from like what question people are asked. And another way to think about I often find useful is again centered on users' needs. What is their needs to achieve understanding? And formalize one is what is their current mental model of AI in general, the particular system you are developing, and what is the mental model they should get to reach their user objective, whatever user objective they are, whether for decision making, for use the AI system leisurely, they might have different mental model they need to get to. And once you formalize these two sets, you will see the gaps in between where things are. So again, might not be algorithmic explanation. It could be they need AI knowledge gap to be filled first, understand how AI works, understand how what a particular terminology means. So that's the analysis side. And another side we also emphasize in this design process is to do it iteratively. To have a design and see how they react. Very commonly, we also use just Wizard of Oz method, right? We just sketch a kind of design of explanation even without building the model to show user how do you think about explanation? Can you make sense of this information on this design? And that will also help you to quickly identify where is the gap of design, where is the gap of their understanding, and that can help you identify the right feature to design. Hope that helps. Thank you.
Yeah, thank you. Oh, and can I have like one last question?
Yes.
And the other question is, I found some like in my just like pilot study, I met some users and they were also interested in the explanation better, not only about the models, but also how the system view their own profile or how they represent the user. So like, do you think that could be another way of explanation? So it is not model, but like how they perceive the user. Yeah.
I'm trying to understand further. So users their own profile or other people's profile? How is it different from the decision process?
So what I mean is like the system like provides recommendation based on like recognizing the user. So like user want to know about how the system perceives me. So yeah.
Right.
So
yeah. Right. That's an interesting question. I think it's part of expandability for sure. It's how the system work, right? We do have this question in terms of input and output, right? The input is matters in terms of how the AI get the data, how the AI does the censoring, and output means like what is the scope, how do I make use of the data. So I do think that's definitely part of the expandability. Again, maybe there are some technical gaps in terms of how do we generate that kind of explanation. Yeah, so that's maybe your PhD work. So that's really interesting that you are interested in that kind of thing. Yeah.
Thank you for your talk. Yeah, thank you.
Thank you.
We have one more question in the chat from Meike. And the question is actually, you mentioned the performance explainability trade-off. Do you think we always have to choose between explainability and performance? Personally, I'm convinced that we should be able to develop explainable models that are both interpretable and well-performing, although such models might be more difficult to develop. And there is also an example of a work that is going to be presented next week at CVPR.
Very good question. As I mentioned, I think one line of work this field is trying to do is exactly breaking that trade-off, right? Develop new algorithms that perform better, but still be explainable. For example, a more sophisticated rule-based model, more sophisticated linear model. One good paper to read is Synthesia Rudin Stop Explaining Black Box Model, including some of the algorithms they developed. So definitely a lot of that kind of work, and it's definitely something the field should work towards. There are contexts that we just should not use black box or post hoc explainability. But I also want to point out in practice, it's not always possible or desirable to use some of the newer algorithms. One reason is there are new algorithms that can perform better, but usually in average setting take more human work to construct. You might need to put more work into feature engineering, for example, and that's not necessarily desirable for practitioner. And there is also instance, actually pretty often, practitioner use a pre-trained model, off-the-shelf solution. They just don't have access to the underlying model. So I still believe there will be places for post hoc explainability, and I do think the field will need both. So that's my view. Yeah. Thank you.
Thank you very much. I see that we don't have other questions, and I think in the interest of time, I would like to thank you again for all the work that you shared with us and your thoughts. And yeah, I would like to welcome you for the next session next week, where we continue with the seminar series.